Learn from TutorDA. Consider the piecewise function f of x equals is defined piecewise x square if x is less than or equal to 1, and 2x minus 1 if x is greater than 1. At which point is f not differentiable? Option A, x equals 0. Option B, x equals 1. Option C, x equals 2. Option D, it is differentiable for all x. Check differentiability at the boundary x equals 1. Left derivative, if x equals 2x for x is less than 1, so f minus 1 equals 2. Right derivative, if x equals 2 for x is greater than 1, so f plus 1 equals 2. Since f minus 1 equals f plus 1, f is differentiable at x equals 1. Consider the piecewise function f of x equals is defined piecewise x square if x is less than or equal to 1, and 2x minus 1 if x is greater than 1. At which point is f not differentiable? Hence, the correct option is D, that is, it is differentiable for all x. Let g of x equals is defined piecewise x plus 2 if x is less than 0, and x squared plus 2 if x is greater than or equal to 0. Where is g not differentiable? Option A, x equals minus 1. Option B, x equals 0. Option C, x equals 1. Option D, nowhere, it is differentiable for all x. Possible issue only at x equals 0. Left derivative, for x is less than 0, g, x equals 1, so g minus 0 equals 1. Right derivative, for x is greater than 0, g, x equals 2x, so g plus 0 equals 0. Since g minus 0, g plus 0, g is not differentiable at x equals 0. Let g of x equals is defined piecewise x plus 2 if x is less than 0, and x squared plus 2 if x is greater than or equal to 0. Where is g not differentiable? Hence, the correct option is B, that is x equals 0. Define h of x equals is defined piecewise x squared plus x if x is less than 2, and 4x plus b if x is greater than or equal to 2. For which values of a and b is h not differentiable at x equals 2? Option A equals 0, b equals minus 4. Option B equals 0, b equals minus 8. Option C equals 4, b equals minus 8. Option D equals minus 4, b equals 0. Differentiability at x equals 2 requires continuity and equal 1 minus cited derivatives. Continuity, for plus 2a equals 8 plus b, so b equals 2a minus 4. Left derivative, hx equals 2x plus a for x is less than 2, so h minus 2 equals 4 plus a. Right derivative, hx equals 4 for x is greater than 2, so h plus 2 equals 4. Equal derivatives, for plus a equals 4, so a equals 0, then b equals minus 4. Define h of x equals is defined piecewise x squared plus x if x is less than 2, and 4x plus b if x is greater than or equal to 2. For which values of a and b is h not differentiable at x equals 2? Hence, the correct option is A, that is a equals 0, b equals minus 4. Determine where the function p, x, equals is defined piecewise, x minus 3, if x is less than or equal to 3, and x minus 3, if x is greater than 3. Is not differentiable. Option A, x equals 0. Option B, x equals 3. Option C, x equals 6. Option D, it is differentiable for all x. Subscribe to get more videos like this. Share if you know any student who needs it.